So here's the code for my revised attempt at creating the 3-button, 3 LED using only state machines. Here I defined the monitor buttons to monitor all 3 buttons. Start by setting the ISR to null and putting the 3 pins into the ISR, moving that to Y. And if Y is empty, just repeating that whole process. And then if Y is not empty, we check the green button. I loaded up the green button, and my buttons are wired backwards from yours, I think. So for the green, it'd be a 100. If X isn't Y, we'll jump to checking yellow. But if it is, we'll set the IRQ to block 0, and then once that's cleared, we'll jump to the wait, which basically bounces the button, where we basically check to see if the 3 pins are all zeros, and if not, we just keep waiting for them to go back to 0. If it's red, it sets the IRQ to block and send it to 1, and if block 2, we set the IRQ to 2 and send it. And then this is what allowed me to do it, because I was having trouble. I was originally had 3 different LED toggle functions, but then I could not fit this wait loop, so my buttons were not debounced at all, and it wasn't functioning properly. So what I learned was there's this relative 3, which basically allows it to toggle based on the relative to the state machine. So it uses a mod 4. I had to do some Googling to figure this out and then understand this. But it takes this, adds it to the state machine, and divides it by 4, or mods it by 4. So in any case, this allowed me to use the same LED toggle function. Saved me a lot of lines of code, enough to add this wait button in. And then you just have the 3 separate state machines that control the different LEDs. So it's probably still not as compact and smooth as what you're going to show us, but it does, I think, show another way to do it. So this is the revised device for controlling 3 LEDs with 3 separate buttons using state machines. I'm now using only 1 PIO block for state machines. And it works exactly as the other one did. Smoothly, no bounce.